Today's ITE is brought to you by PCs for Maine, the leading project from Information Technology Exchange. Desktops and laptops are used in homes around the world. The age of the personal computer came quickly and stuck around, with innovation leading the way in their evolution and simultaneously relying upon them. What we know as desktop computers are really computers with peripherals. Those peripherals are a monitor, a keyboard, a mouse, and sometimes speakers or headphones. A laptop has the same parts as a desktop, only they are smaller, more difficult to customize, and kept in tighter spaces. Let's take a look outside the box at all of these peripherals. The monitor is the screen which attaches to the tower. It provides the output of the machine, which means it displays the data and information so that it can all be understood. The mouse is a tool for input. The mouse lets you tell the computer what you want it to do. Most are made up of 2 buttons and a scroll wheel, but sometimes they get funky. Ergonomic mice are designed to limit the strain on the wrist and fingers. Gaming mice have buttons on them to enable a very coordinated user to do more things at one time. On laptops, there are touchpads with buttons, and sometimes there are button cursors in the keyboard. The keyboard is another input device. It allows the user to input letters, numbers, and punctuation. It even has navigation abilities with different operating system commands. Just as with mice, there are other types of keyboards. The ergonomic keyboard for comfort and health, and the gaming keyboard for ease of access and customization. Keyboard layouts have changed a lot from what we had with typewriters to now. There are varying layouts nowadays, mostly dictated by regional or national language use. The tower is the housing for the actual computer. It protects all of the hardware inside of it from the elements, dust, hair, pets, and sometimes food. All the input and output happens under protection of the tower. Now let's venture inside the box and see what makes a computer compute. All of the computer hardware in your computer connects to the motherboard. Your computer processing unit, expansion cards, memory chips, and even data drives must all be compatible with the slots and sockets on the motherboard. Whether you are building a new computer or upgrading your old machine, the hardware must match the motherboard. The CMOS battery, which stands for Complementary Metal Oxide Semiconductor, maintains the settings built into the motherboard. These settings are important items like the date and time and the motherboard's configuration. If these items go out of whack, the computer will definitely not run the way it is supposed to. The CMOS battery ensures that they stay put. The computer processing unit, called the CPU, is the brain. It handles calculations and instructions for all the programs that you run on your computer. This piece of hardware takes the form of a chip that slips into the motherboard. As with all other items, the CPU must be compatible with its motherboard. CPUs are rated in 2 ways: the number of cores and the speed. Computers range from single core up to the 70s. The difference between a single-core CPU and a multi-core is complicated. The single-core machine is measured based on the time it takes to execute all tasks. It is rarely used nowadays. The multi-core machine is based on the time it takes to complete a single task, because there are multiple cores to handle their own tasks. For speed, computers measure in hertz, which are cycles per second. A CPU can run between 500 MHz per second to 5 GHz per second. Newer machines average between 2.5 and 3.3 GHz. That's over 3 billion cycles. Motherboards have specific sockets for random access memory, or RAM. RAM allows your computer to handle multiple programs at once, and adding additional RAM can significantly improve the speed and performance of your other computer hardware. RAM acts as a messenger between your commands and the CPU, so helping your messenger to be as fast as it can is ideal. RAM comes in multiple types called channels, and a motherboard will be made to handle only one of these. It is a good habit to have the RAM match each other as pairs in order to get the best performance. Motherboards have expansion slots for miscellaneous components such as graphics cards. Just as before, remember that the hardware you want to install needs to match the motherboard slots. It is important to note that not all slots are available on every machine. The most common slot types are PCI and PCI Express. If your motherboard features support for multiple graphics cards, you can get pretty extreme and use 2 computer hardware expansion cards together for an extra performance boost. The optical drive will often run both CDs and DVDs, but it is always better to check first. Discs are written to through the use of lasers, and the data is stored on the shiny underside. Be careful, even oily fingerprints can hinder the quality of the disc being read. CDs can be written to once, but they may be read many times. So, you can load a music album onto a CD once, but you can listen to that album more than once. CDs can store up to 700 megabytes of data. DVDs, like CDs, can be written to once, but read many times. A DVD can hold up to 4.7 gigabytes of data. SATA and IDE interfaces allow you to connect to hard drives, solid-state drives, optical disk drives, and other data devices. If your motherboard has multiple interfaces and supports special configurations, you can use multiple hard drives on the same machine. IDE drives are hard to find nowadays and are rarely used, except in the repair or evaluation of older machines. Hard drives can range from small to large amounts of storage. The hard drive enables your computer to store and run programs, files, and features. It relies on its moving parts, like an older clock depends on gears. A solid-state drive is entirely electronic with no moving parts. It is faster, more reliable, and more eco-friendly due to lower power consumption, though it is more expensive. Removable disks are used to store information for later use that you may want to bring to another computer, to back up your current computer, or to install software. These data devices use either optical drives or ports on the computer to be read. Like all hardware, they must be compatible with both the computer's hardware and software. The power supply is where the power cable plugs in from the wall, and it supplies power to the entire computer. Everything from the motherboard itself to the little blinking LED lights on the case are all powered by the large box with a fan inside the computer. To maintain order in the chaos of the tower, zip ties, special cables, and even special compartments are used to keep cables organized. So let's review what we have learned today. In Part 1, we learned about monitors for display, mice for input, keyboards for input, and the tower for protection. In Part 2, the lesson got more difficult. We began with the motherboard, the central part of all computers. Everything connects and runs through the motherboard, which they must be compatible with. We then looked at the CMOS battery, which maintains all the settings for the motherboard so it runs the way it is meant to. Next, the CPU, which is the brain of the computer. It handles all the calculations and instructions for the computer. We then talked about RAM, the messenger for all the data to be sent between the user and the CPU. After that came expansion slots, which allow for customization and optimization of miscellaneous features. Then came the optical discs, CDs and DVDs for data to be stored, transported, and read as many times as a user would like. Data drives followed, where we discussed the older IDE connections, the SATA connections, and the difference between hard drives and solid-state drives. Removable disks are transportable devices that allow a user to take data wherever they need to. The power of the computer comes through a large box called power supply. The power goes through the motherboard, which then delivers the power to all the components that need it. With that, we concluded with the idea of cable management to maintain order in the chaos that happens inside of the protective tower. Congratulations! You have completed this chapter of the Computer Fundamentals course. This video was made possible by these sponsors.